Okay, so someone requested from section 5.3, question number 10, dealing from a standard deck of cards. It's on page 287, again, of your textbook, not of the PDF. All right. And so what I have is I have this sort of the deck of cards subdivided into suits, because a lot of the questions here are about suits. And when you subdivide them into suits, there are sort of subgroups: hearts, clubs, diamonds, spades. And these all represent this sort of problem-solving process. Now, what we're going to be getting for the very first question, how many different 4-card hands can have at least one card from each suit? Okay, so it's a 4-card hand. So my hand, this is my hand right here. It's a little group put in my hand. Okay, and this is the deck of cards. Okay, assume they're all randomly shuffled. All right, and then I'm going to get one from every suit. So I'm going to get one from hearts, one from clubs, one from diamonds, and one from spades. 1, 2, 3, 4 totals to 4. There's 13 hearts, 13 clubs, 13 diamonds, and 13 spades. So in this case, what it would look like is this. We've got 13, choose one. Okay, that's hearts, and 13, choose one, that's for spades, and 13, choose one, that's for clubs, and 13, choose one, that's for diamonds. Because it's this and this and this and this in the same hand, we multiply. And so the number of ways is going to be 13 to the power of 3, 13 to the power of 4, which is whatever number it is. I'm not really concerned about what that is. You can figure that out yourself. Okay, so that's how you would figure out the number of 4-card hands that have one of every suit in them. For 10B...
Kevin, get out of the cat's food. Just keep going. Keep going.
For B, it's how many different 5-card hands can have at least one spade. Okay? And there's a bunch of ways to do that. It's a bit problematic, to be honest. Okay? When I graph it out, or when I sort of show the work, and I'm going to have to erase this and do the work over here. We've got spades, right? Oops. We've got spades, and then we've got everything else. We don't care what everything else is, so we can call them spades and we can call them not spades. Okay? So in the case of not spades, there's going to be 39 not spades. Okay? And we're getting a 5-card hand. Okay? And then we're going to have a bunch of different cases, because we could have no spades, 1 spade, 2 spades, 3 spades. In this case, we're going to have some spades and some not spades, because we have to have at least 1 spade. Okay? So just let me erase this super quick. Okay? And I'm going to show you the different cases. And then what we'll do with the cases is we'll add them up, and I'll show you a faster way to do this one. Hopefully I can get this dry enough. I might have. Okay, so the answer is going to go over here. All right, so case 1 is going to be 1 spade. And so 1 spade is going to look like this. It's going to be 13, choose 1. That's 13, one of those, and 4 not spades. And 39, choose 4. Okay? For case 2, that's going to be 2 spades. My number is going to be 13, choose 2, plus 39, choose 3. If I have 2 spades, 2 spades, then I'm going to have 3 not spades. Okay? For case 3, I could have 3 spades. My number is going to equal 13, choose 3, oops, times 39, choose 2. And again, it's multiplied because I have 3 spades and 2 not spades. For case 4, it's going to be 4 spades. And my number in that case is 13, choose 4, times 39, choose 1. Okay, 4 spades and 1 not spade. And my final case, case 5, is going to be with 5 spades, which is going to be kind of, well, relatively boring compared to the rest of this, because it's going to be 13, choose 5, which is all 5 spades. And I guess you could say and 39, choose 0, which is 1. Okay. Now, what would we do with all of those? Well, what we would do to find the total number is case 1. Okay, you can have 1 spade or 2 spades. So you'd add case 2. Or 3 spades, you'd add case 3. Or 4 spades, you would add case 4. Or 5 spades, you would add case 5. and then you would get the final answer for that. It's a long, sort of involved process, okay? But that's how we would do it, by breaking it into cases. Another option that we could have with all of that, it's a little trickier, okay, not a lot of people would see it, is by using the indirect method. Okay? If we use the indirect method, again, the strategy is, hopefully that's going to be dry enough. The strategy is for the number with at least one spade, that's equal to the number total, all possibilities, minus the number with no spades. What's left is something with 1 spade, 2 spade, 3 spade, 4 spade, 5 spade, which is exactly what we want, all these cases added together. The total is going to be 52 cards, choose 5. Okay, that's these guys put together, choose 5. And we subtract 39, choose 5. In which case, we actually choose 5 from here, and we choose none from here, or just 39, choose 5. That should get you the same answer as doing them all separately. Now, I think if you do it this way, it shows you really know what you're doing. But if you're doing it this way, you're very, very, very clever. Does it matter which way you do it? No, both are correct. Okay, both are a good way to do it. Okay, I don't know if there was a part C. Is there a part C in there? Yeah. How many different 5-card hands can have at least 2 face cards? Jacks, queens, or kings. At least 2 face cards. Okay, I think I'm going to do cases for that one too. Have a quick peek at that. Can you get a good look at that just so they can pause it and copy it down if they want to? Remember, this is one answer, or this a bit faster, but I think both of them are good. Okay, that should be good for people to pause and copy. We're going to do C now. And part C, it's going to be dealing with other things other than suits, okay, because it's dealing with types of cards like jacks and queens and kings. In this case, face cards. Face cards are all the cards, obviously, that have the faces on them. So there's a queen, king, and a jack. They're all face cards. And then in the queen, king, and the jack, there's one of each from every suit. So in spades, there's a queen, king, and jack. And in hearts, there's a queen, king, and jack. And in diamonds, there's a queen, king, and jack. And in spades, there's a queen, king, and jack. So there should be 12 in that particular subset, or in that particular part of face cards. So it's going to be kind of the same scenario. But instead, we're going to be doing a bit different of a grouping. Okay? Let's see a few prayers. Hopefully this thing's going to be dry now. Let us do some work here. Okay, so the groupings look a little bit like this. Okay, so I've got face cards, and we got 12 of those. And then instead of having not spades, or sorry, what do we have? Not spades, in this case we have not face. Okay, so not face, there's going to be 40 not face cards because they got a total of 52. And again, it's a 5-card hand. I'm going to look for the number with at least 2 faces. Okay, so case 1 is going to be 2 face. Okay, and so the number for that is going to be 12, choose 2, and we need 3 other cards, so it's going to be 40, choose 3. Okay, case 2 is going to be 3 faces. Okay, and the number is going to be 12, choose 3, times 40, choose 2. Again, totaling to 5 cards, 3 face cards and 2 non-face cards. Case 3 is going to be 4 faces. Okay, which is going to be 12, choose 4. There's my 4 faces, and we still have to have 1 extra card. Okay, 40, choose 1 from anywhere else. We don't care where it comes from. And then for case 4, we have all faces, or I guess 5 faces. Okay, and so the number would be 12, choose 5. And I guess you could, you don't have to. And 40, choose 0. Okay? And again, it's going to be the same scenario. The number with at least 2 faces is going to be case 1 plus case 2 plus case 3 plus case 4, because you could either have 2 faces or 3 faces or 4 faces or 5 faces, or the super fast way to do it would be a number with 2 faces, or I said I should say at least 2 faces is going to be all minus no face and minus 1 face. So it would look a little bit uglier, but all again is 52, choose 5 cards from a deck of 52, minus no face, that's going to be 12, choose 0 times 40, choose 5, and then also subtracting 1 face, which is 12, choose 1 times 40, choose 4. I guess I can kind of put a little barrier around that, and when I go to do that, kind of an indirect method, but a little bit tougher of an indirect method to do. Okay, so whichever way you want to do it, the right or the left, all of those are going to be for part C, and that's at least 2 face cards. Okay, if you can do these ones, you're pretty good for most card hands, I think. You're in pretty good shape. Okay, that's it.